Okay, there was a question. I struggled with the exercise the next leap year, and even after speaking with others, we could not find a solution to the exercise. Please go over that exercise, maybe explain the way to the correct solution. Well, I think it all boils down to the fact that you need to figure out how to determine if a year is a leap year or not. And figuring out if a year is a leap year, I think there are pretty detailed instructions to, or pretty detailed rules to that. So the idea is that the year needs to be divisible by 4. So I'm not going to give you the solution, of course, but if you try something equals give a year, let's call it the year instead of y, because that's how we're supposed to name the variables. So the year must be divisible by 4, but if year is divisible by 100, then it needs to be divisible by 402 for it to be leap year. And I think a constant, sort of a common problem with this one is that when you have these rules, you start implementing them one at a time, starting by if it's divisible by 4, and that's not going to work. Yeah, there's a previous exercise in part 1 that describes how to check for a leap year, which should help you with this one. But just to give you a sort of a hint for this one, if you start by checking if a year is, if you start by something like this, if year is divisible by 4 by using the model operator, and then do something more, this is a wrong way because what's the problem with this one? Like if we then do that if year divisible by 100 equals 0, and so what's the problem with this one? And this is a really important thing, and this is actually one of the reasons why we have this. I mean, calculating the leap year is really common sort of exercise. I think we do that in most, or people do that in most programming courses, and there's a reason for that. But what's the problem with this one, if you think about it?
Because it's not true in every case. So we have to start from the other end in a way, from the most rarest exceptions as opposed to this end.
Yeah, you're exactly right. So the thing is that every year that is divisible by 100, it is also divisible by 4. Because 100 is divisible by 4. 25 times 4 is 100. So you need to start with this sort of exception. So check like the rarest case as you said first. Check first if the year is divisible by 100, and then check if it is divisible by 400 as well. And then if those are not true, if it's not divisible by 100, then you can check if it's still divisible by 4. And then coming up with the next leap year is basically just that you start with the current year, and for each year in a loop, you check if it is a leap year until you find the leap year, and then you can break out of the loop. So basically, if you can detect if something is a leap year, then it's just a matter of doing that in a loop, starting from the given year and going until you encounter a year that is a leap year. So I think that's pretty much what I can help you with right now. By seeing your code, I could maybe provide something else, but then we need to do that in this code. How to bring the variable year in a loop? I mean, that shouldn't be too difficult. If you get a year, then you just do something. You can do something like this. You want to, and then you check if leap year in here. If it is, then you break, and if it isn't, do year plus equals 1, and then continue the loop. So this is basically how it doesn't need to be more complicated than this one. So you do the leap year check here first, and if it is a leap year, you break out of the loop. If it isn't, then you increase the year by 1, and then you continue doing the loop. And doing the while true for this one is perfectly fine. Although we're going to talk about different conditions today as well, but this I think is the way to do this. First check if it is leap year. If it is, break out of the loop. If it isn't, increase the year by 1, and then keep on doing that until you encounter leap year. And it's a safe thing to do because eventually you will encounter a leap year. I mean, it shouldn't take more than, I think, 7 iterations is a maximum you can do, and then you will encounter a leap year. Does this make any sense? Okay, ask away. Please keep asking if you have any. We can get back to this also at the end if you still think that you don't get it. It's not that easy. It is a bit more difficult task, especially since this is something we haven't really done yet. Yeah, you can also start from year 0, but then you're doing a lot of sort of excessive calculating. You don't really need to calculate all those years between the 0 and the given year. I mean, that one works, but you're doing a lot of excessive calculations for that one, because you can start from the given year and then just go on from that until you encounter a leap year. So it works if you start from 0, but all the leap years you calculate between 0 and the given year are sort of done. You don't need to do those. I mean, that's just not needed. Okay, let's get to today's lecture. So last week we talked about conditional statements. We talked about those additional conditional statements in addition to if, like elif and else statements, and then we talked about logical operators on how we can form more complex conditional expressions by joining separate expressions with those logical operators and, or, and not. Or not is not for joining, but and or, basically. And then the final thing last week was the simple while loop, the while true loop. There were, for some reason, parentheses there. There were a couple of questions, a couple of sort of common questions. I checked the Discord and your feedback, and there were other questions as well, but I think these were ones that occurred quite often. There was one about using external editor. You all start using external editor next week. So starting from part 4, you can't do the exercises in the browser, but there are really detailed instructions on how to install everything needed. So you need to install the VS Code, the editor I'm using for these lectures, and you need to install an addition to VS Code called TMC plugin, which then connects your editor to the MOOC, meaning that you can then do the exercises in the external editor. You can start using it already if you want to, but you need to start using it at part 4. I'm going to show you a brief introduction to how to use it next week, but it's actually not that complicated. It's pretty similar to doing the exercises in the editor or in the browser editor, but the editor in VS Code it's much better, so it's actually nicer to write programs in there. And then there was a question about, and this also came from some of the instructors, whether it's okay to send private messages to instructors to ask things, and I'd say that, or how do we want to do it? Is that when someone is having like a scheduled time in Discord and they announce it in the Discord saying that this is their hours, instructing hours there, you can send the private messages there during that time. But after those hours, please don't send private messages to our student instructors. And as I said before, all the instructors are are also students and they have other responsibilities in their own courses and things like that. You can also always send messages to me and other teachers, but don't send them to the instructors outside those dedicated hours. And yeah, good question. Can you do all the parts at all time around? I didn't finish part 2 yet. Yeah, all the parts are open until the end of this year, meaning that you can complete them however you want to. But as I said, I sort of recommend that you try to finish one part per week. If you're missing some exercises from part 2, that's not a problem at this moment. But it's a good idea to try to finish the whole course during these 8 weeks, and then because then you can continue with the advanced course in the schedule. But if you're at some point get left behind a little bit or something like that, that's not a big problem, I think. Okay, so let's see what we. Oh, question, can we get more instructions on proper indentation? Yeah, we're going to talk about indentation today as well when we talk about nested loops. So yeah, we're going to continue about that as well today. What we did last week was basically something like writing, or this was like the final thing we did last week was writing loops by using the while loop, while true loop, basically. And the idea was that we use this basically, for example, in cases where we query something from a user, like give a number, and then we need to define something like a condition where this loop terminates, something like this, and then we can check that if the number is equal to that terminating condition, we can break out of the loop by using the break statement, and if it wasn't, we can output something like the square of the number is which number, second or number times number, however you want to calculate it, like this. And if we execute the program, we see that it asks for a number, and it keeps giving us the squares of those numbers until I give -1, and then the program terminates. So this is pretty much what we did. The most of the exercises at the end of the last part were about this one. Now, if we take a look at the while loop, how it actually works, it works pretty similarly to conditional expression or conditional statement. So in the beginning, there's a conditional expression. If it's true, then we execute a block. And now the difference between the iterative statement or a loop to a conditional statement is that after the block is executed, we go back to evaluating the conditional expression. And this keeps on going until at some point the conditional expression becomes false, or we break out of the loop by using the break statement. So a conditional loop, a repetitive statement, is basically similar to conditional statement, except that it keeps on doing this over and over again. That's why we call it a loop. It's like something that goes on until this expression becomes false. And now one important thing to realize is that if this expression is false to begin with, then we don't execute the block at all. So with the while statement, which is basically not the only loop statement in Python, but still like the basic loop statement in Python, we check the expression before executing the block, meaning that in some cases we don't execute the block at all. So let's try something else. So for all the loops we've been having so far, the conditional expression has just been the Boolean value of true, meaning that it's always true. So that the only way to stop the execution is to encounter, or is when the program encounters the break statement, or then just killing the process by clicking the kill button here on the console window. Or if you're doing this in a browser, if you do like an infinite loop, then it stops automatically at some point. Let's try something else. Have you seen this plus equals operator before? Was this discussed in the material somewhere? Who has seen it? Let's say it like that. Do you know what it means? Well, let's say that. Okay, so yeah, so this is basically similar to value equals value. Oh, missing a character. Value equals value plus one. There's someone raised their hand. You can type your question in chat window, but if you want, you can also ask it out loud. But Daniel, you have your hand up. I don't know if it's on purpose. Probably not. Okay. And then we can use this with all these basic arithmetic operators. We can do something like value time is equal to, which is again equivalent to value equals value times 2. And this is a shorthand. I mean, the sort of the advantage is that it's a bit faster to write, probably, especially if your variable name is a bit longer. I think it's okay to use it. It's readable. It's sort of easy to see what it means in here. So it increases the value of value by 1. Okay, so what happens in this program? Let's try it out. So let's give a number something like 5. And what do you think the program does? What is the output? Yeah. Yes. The value times on 2 means that value equals value times 2. Similarly, then value plus equals 1 means that value equals value plus 1. It's the same exact thing. It does output 4, but it does output other values as well. So let's try it out. So now it outputs all the values between 0 and 4. Okay, yeah, you were getting there. So we had so what happens in here is that we have now we have 2 variables. We query the user for a number, and then we have a separate variable value which starts at 0, and then our loop goes on as long as the value is smaller than number. So what happens in this program that Python first checks that, okay, is value smaller than number, and because 0 is smaller than 4, 5, which was given, it outputs 0, then it increases the value by 1, then it goes back here, and again it checks if value is smaller than number. Because 1 is smaller, it outputs 1, and it keeps on doing this until at some point. At the end, it outputs 4, then it increases the value by 1, so value becomes 5. And then it checks that is 5 smaller than 5, and because it isn't, then it terminates the execution, and then the execution continues after the block. So if we have like another statement in there, let's re-execute this. Then it executes the statement after the block is terminated. Yeah. Okay, let's try something else. Let's try another value. What if I give a number 10? What is the final value output? It's a good question. Why 0? Yeah, good. Is it going to output 10? Yeah, it stops at 9. Why? Why doesn't?
Because says that while the value is less than the input number, it's not says equal to the input number. So in that case, the number is 10, which means that the integer before 10 is 9, so it has to stop at 9.
Yeah, exactly. That's a really good, that is exactly true. Thank you for that. And there's a really good sort of summary about that one in the chat window, saying that you increase value after print, and this is exactly the reason. So we output to 9, then we increase the value by 1, and the value becomes 10, but 10 is not smaller than 10, so we don't execute the loop or the block in that case, meaning that we don't output 10. But if we output the value after the loop, and now this is also important. So, okay, let's execute that. So let's run this again. Wrong indentation, and well, someone asked me to ask if we could discuss the indentation more, and as you see, Python is really sort of, you need to really pay attention to the indentation. So this needs to be at the exact same level than all the other statements in the block, meaning that if there's an excessive space, then that's an error stating that unindent does not match any outer indentation level. So Python doesn't know which block this statement now belongs. So it needs to be here, or it can be here, but it cannot be somewhere in between. Now we had a lot of questions. Let's check this one first, then let's talk about printf. So let's do it again. Let's say that I now give 10. So it outputs numbers from 0 to 9, but then it states that value is now 10. And this is important also. This is something you need to consider, that what is the value of the variable after you exit the loop, if you're going to use that value for something. And this can be misleading. So you need to be really careful on where you actually change the value of the variable in a loop. So in this case, we increase it after we output the value, meaning that the final value we output in a loop is 9, but the value of the variable value after the loop is 10. And this might make a huge difference in your program if you don't consider that. The printf, I think this was included in the material somewhere. So the f have you seen this before? Have you seen the f string thing before? Because I think at least in the Finnish lecture we discussed and it was sort of familiar. The idea of this one is that it's in the material as well, so I'm going to give this brief. So when we include this lowercase f before the string, we can then insert the variable values in the string by using these curly brackets, I think you call them. So it's easier if you want to, it's easier to format your output by using this. And this is instead of using that command and separating those different variables and string constant with that one. Where do you get the curly brackets? It really depends on your keyboard layout, on which country layout you're using. If you're using a Finnish layout, then pressing Alt-TR and 7 and 0, I think, are the ones on most keyboards. But it really depends on your layout. So if you're using like an English keyboard, for example, then it's somewhere else. So in Finnish one, Alt-TR or whatever, that at least in Unix and Windows machines, and then 7 on 0 on the top row. So Alt-TR is the one usually right to your space button. Space key, I think. Okay, yeah, let's change this a little bit before we do anything else. So if we increase the value first and then output the value, then the outcome is something different. Let's execute this again. Let's say that values, I give a 5. What are the values output now? You can just say from something to something or So if we first increase the value, then output it. What are the values if I give 5 as a number? Not exactly, no. It doesn't start at 2. It starts at, where does it start? It's a good choice.
0.
It doesn't have a 0 either. Think about what happens inside the loop. Value starts from 0. Yeah, 1 exactly. So it's already there. I sort of forgot it. 5. So now it outputs numbers from 1 to 5, and then after the loop, the value is also 5. And this is logical if you think about it, because we first increase the value of variable value by 1. So before we output anything, we increase it by 1. So it starts from 0, it becomes 1, which is then output, and then it increases 1 step at a time. And after outputting 5, the 5 is no longer smaller than 5, so we exit the loop, and then we output that value is now, and now the value is the same than the final value output. But you need to, this is really sort of a common source of error, especially when you start with this, but also later. It's really easy to mess this up. It's really important to think that where you change the value of variable in a loop. Okay, let's try something more and then move on. Okay, let's say that I give a number something like -5. What does the program output? It does output -5, but does it output what does it output in the loop?
It still starts from 0, right?
Does it?
Because it says that the value, if it's less than, but the value is greater than.
Yeah, there's a yeah. There are actually in chat window there are a couple of good. And now this is something you need to remember. In Python, before the loop is executed, we check, or Python checks the condition. And in this case, if we provide -5, it checks that if 0 is smaller than -5, and 0 isn't smaller than -5, this is false. So the block is never executed at all. So the execution continues in here and states that the value is now 0. If you get rid of this one and execute it again and give something like minus whatever, oops, let's not do it over there, -3 or -5, it doesn't output anything. It doesn't execute the loop at all. So as I said before, and as you might understand from this fancy picture, is that we first check the expression. If it's true, we execute the block, then the expression is checked again, and then this goes on and on and on. But if the expression is false to begin with, then the block is never executed. So in that way, this is similar to if statement, to conditional statement, that if the expression is false, then the block is not executed. Then the execution continues after the block. For each loop, we identify 3 components. We can identify 3 components, and these are all important for the loop. We have like the initial part where we set the initial value to the variables used in the condition. Then we have the condition, which is, well, that's actually quite simple because we need to include one when we are writing a while loop. And then we need to have a part, the change part, or the update part, where we update the variables affecting the loop. So it's quite typical to do something like this, that we output the value and then we forget to change. So what happens here? Let's say that I give a number something like 3. What does the program output? Yeah, it outputs a 0. What else?
1 and 2.
Does it output? Tell me, why would it output 1? or 2?
Because the number 3 and the value is less. The number 3 is greater than the value.
It is,
So-
yeah, but does it change the value of variable value anywhere?
Oh, no, it doesn't. It doesn't, because we don't have the plus
Yeah.
equal
Oh, so
sign.
what actually happens here?
It's true. That's it.
Yeah. And again, I think we have an excellent answer in the chat window. It will be infinite. We talk about the infinite loops. So what does it mean? Let's try it out. Type in 3, and what happens here? We get a lot of zeros. It keeps on outputting zeros over and over again, and it does that until we actually kill the process over there. So we talk about infinite loops. Of course, they are not in practice. Nothing can be infinite in programming, but we talk about infinite loops because an only way to stop this loop is by terminate it sort of forcefully, to kill the process like that. And sort of the only way this program can ever terminate is that if I provide a negative value, because then the loop is not executed at all. But if I provide a value that's larger than 0, then it keeps on outputting the same number over and over again. And this is problematic in a lot of senses. And this is something you will also probably do at some point. And this is something that even quite experienced programmers do at some point. Probably nothing loop this simple, but when you have a more complex loop, you're doing something inside the loop. For example, do something with the leap years, and maybe you have a little small problem in your algorithm, so it doesn't recognize the leap years or something like that, and then it just keeps on increasing the numbers and outputting them, and so on and so on. This is problematic in the sense that in some programs take a lot of time to execute. There are some really complicated sort of problems where the solution might take a lot of time. And sometimes when you're trying to solve that kind of problem, it might be difficult to know if it just takes a lot of time or whether your program is actually stuck in an infinite loop. And this is so this is something you probably encounter when you're doing something a bit more complex, but it's a real potential problem, and that's why usually when we're doing something really complex, we do something like during it, like let's output something every 10 minutes or something, just to make sure that the program is still doing something. And that's why when your computer is doing something that takes a lot of time, you know this progress bars, you see that there's like this blue bar or whatever color that keeps on getting bigger, so that you know that your computer isn't like halted there or isn't frozen, but it is actually doing something that takes a lot of time. This question, what is the initializing bug the program freezes? Sorry, I don't really get the problem with this one. The bug in this one is that we're missing the third component, the update component of a loop. So we basically need to have all these components. If we're missing the initialization part, then we usually get an error if you try to use a variable that doesn't have a value. And the condition we must include all the time, but the update part is something that we typically forget. Or typically, but sometimes forget, and then we encounter an infinite loop.
So in the exercises, I noticed that I was stuck. It didn't give out an error message, but it wrote initializing, and it's almost like a rantapallo that doesn't go forward. So I noticed that there's a bug in my code, but it says initializing, and it looks like it's processing, but nothing happens. So then I have to break out of it and try to fix it for it not to happen. But I guess it has to do with the initializing statement or something like that.
It might be. It really depends on if you're doing this in the browser. It might be because of that. I think in those cases, if you don't know what causes, it's a good idea to ask that in Discord or wherever, because it might be something else. There is this. We encountered a small bug in the browser editor actually, where if you're trying to convert a floating point number into integer number, then it doesn't really give you any meaningful error message. It just states that there is no output in your program. So it might be a good idea to ask, but usually if it just keeps on going, it means that you have an infinite loop and it never terminates. It should automatically terminate. The browser editor should automatically terminate those programs, but if not, then it's a good idea to show the code and ask what's the problem with that one. It's difficult to say without seeing the code. Okay, so let's rewind a little bit and let's get back to what we did last time. We had a lot of these loops where we have this while true, and then we query for a number, and we have some kind of terminating condition. Let's say it's a zero at this point, and then this is something we did already today. Then we break out of the loop, and then we can output something like number times 2 is, and then number times, oops. Those are not the parentheses I'm looking for. Come on, number times 2, something like this. So let's execute. Let's always execute the program. It's always a good idea to execute the program before trying it out. And then when I give a 0, it seems to stop. There's a question, explain the indentation for the breakdown. Whenever, well, to keep it simple, in Python, when the previous line ends with colon, like in this case, we start a new block and that must be indented. So in this case, after this conditional statement, the break line is indented because this belongs to a different block than the lines before. And this block is only executed if this condition is true in here. And in Python, we the blocks are done by using different indentation. So in some other programming languages, there are like special characters which are meant for notifying that this is a block in here. But in Python, the way to create a block is to use the same indentation for all lines in that block, meaning that this line 4 here is one single block following the conditional statement. And this block is only executed if this condition is true. Now, and this statement here belongs to a different block. And this is really important, and we're going to talk about this a bit more in a few minutes when we talk about nested loops. But this can sometimes be, especially when you have a lot of count lines, then realizing what belongs to what block might be sort of difficult at first. Okay, another way to do this program would be to use, instead of while true, is to use the condition in this one, to state that while number, and now the terminating condition was that the number is equal to 0, meaning that as long as the number is not equal to 0, we want to execute this block like this. So what's the problem with this one? The program doesn't work like this. What do I need to insert to make it work? What is the problem with this one? Think about it. If I execute the program, it will give me an error message, but why? There's nothing to do with the actual loop.
Is it we did not define the number before the loop?
Yeah, it's basically yeah. So if I try to execute it, it gives me a name error stating that name number is not defined. And the reason is, as you said, is that we are trying to use the variable number before we have a value for the variable number. So we can't use a number in an expression because it doesn't have a value. The variable doesn't exist. The way to create a variable in Python is to assign a value into variable like we do in line 4, but because it's done after the line 3, we can't use it in this one. So we need to set an initial value to variable number. What would be a good initial value for this variable? Give me something. Give me a suitable value.
-1.
Explain why, but yeah, sorry. Just any value. I think 0 is not a good value, but 1 is perfect. Why Yeah, almost any number is the same, but 0 isn't. Why 0 is a bad choice? I mean, let's say 1, but why not 0? What's the problem with initializing variable number with 0?
Can I answer?
Yeah, please.
Because the while code statement will not work if the number is 0.
Yeah, exactly. So it needs to be something other than 0 so that the loop is executed at least once. And then it doesn't really matter what the value is as long as it isn't 0, because we're going to replace the value anyway in line 4 where we query the user for a number, and then the number given by user replaces the initial value of number. So now when we execute this one, it asks to give a number, and now we can type in the numbers, and it keeps on giving us the number times 2 until we provide 0. What is the difference between this one and using the break? If you look at the output, this might be a bit more difficult, but what is the difference between the program where we checked if the number is 0 and then we use the break statement out, and then this one? If you just look at the output, it's like if I give you a hint, it's the very final things that the program is outputting before it terminates. There's a difference. Yeah, exactly. The whole block is executed. And what it means for this one is that when the user enters 0 to terminate the program still says that number times 2 is 0, because 0 times 2 is 0. But if we do it differently, if we do the while true here, and then we check that if number is 0 and we break out of the loop, and then we execute it again. If we try it this way, then when we provide the 0, it doesn't output the number times 2 is 0. And the reason is that this break statement immediately terminates the loop. But if we do it like we did in this one, oh yeah, this one, then it does output that number times 2 is 0 when we enter 0. Which way do you prefer? Which one do you think is better? And now this is an easy question because there are no wrong answers. But I'm just asking, which one do you prefer? Create a poll if it would be possible in Zoom, but I don't think it is.
I would prefer if it's like very close to 0.
No, but yeah, but like this one or the one using the break statement. Okay, we have some answers, and really there are some who prefer the one with the break command and one who said I will try to avoid break. Both are great answers. There is no, as I said, there is no correct or incorrect answer for this one. These both are actually quite fine. And if you want to get rid of if you don't want to output that the number times 2 is 0 at the end, we can also check that if number isn't 0, then output this one. So we still don't need to use break, but we get rid of the final output if that's the thing. Now there are programmers who prefer one of these in these kind of tasks. And as I said, there's nothing wrong. I sort of prefer using the while true for these kind of things. And the reason is that this is like, we're going to talk about this next week, I think. So this is the kind of loop where we don't know the number of times it's executed in the beginning. In that case, I think it's sort of, in my opinion, it's like more logical to start with the assumption that it's going to go on indefinitely until the user at some point provide a 0 to break it out. But there's nothing wrong in using the condition in here as well. And there are a lot of programmers who actually try to avoid using break, like someone entered in the chat window. And in some occasions, there might be like a style guide saying that you need to avoid using break or something. But in a lot of cases, I think this might be, it makes, in my opinion, it makes it a bit more readable. But as I said, nothing. What I'm trying to say here is that whichever you use, it's fine as long as you think that's the best way to do it. As long as you can justify that this is the easiest, this is the, and one task when you're writing a program should always be that, well, of course, the program needs to perform the task it's supposed to perform, but also one very important goal is to make the program code as readable as possible, make it as easy to understand as possible, so that when you get back to it yourself later or someone else is working on your program code, they can understand what's happening there as easily as possible. And that's why we try to write programs try to make the program code as easy to comprehend or understand as possible. So question, why is the block executed when the input is 0? Isn't the condition false? The block isn't executed when the input is 0. But when we give, I think you're talking about like while number is not 0. And the reason, and that's a good question. We have a lot of good questions today. Again, the reason why it outputs the number times 2 is that it always executes the block to the end before the condition is checked. So when the user provides a 0, it's true that that's not equal to 0. So this is a terminating condition, but it isn't checked until the whole block is executed. So Python executes all the statements in this block and then it rechecks the condition. So when we enter 0, it does execute all the lines that there are left in this block and then it terminates the condition. So it doesn't immediately terminate it. It needs to go to the end of the block before the condition is checked. Okay, then we talked about the break statement before. The break statement immediately terminates the loop. And we can use break statement even if we have a condition in the while statement. So let's do something maybe a bit more simple. Let's say that number is equal to 1 and as long as number is smaller to 10, or what is 100,000, I think. Let's output the number, increase the number by 1, and then check that if number is equal to 3, then break. So what does the program output? So it outputs a bunch of numbers, yeah, from 1 to 3. Does it output 3? Again, I'm asking this question. This seems like a trick. This might seem like a trick questions, but these are really, really important, because it's really important to realize what is the exact point where the loop terminates. Does it output 3? Think about it.
It does, because if it's 3, the loop breaks, but the number is there.
Yeah, but does it output 3?
Yes.
Yeah, it doesn't. Yeah, you're right. And it seems like it does, because it checks that when the number is 3, it breaks out. But again, we output the number first, then we increase the value. So let's try it out. And it only outputs 1 and 2. And the reason for that is that when we output 2, then the value increases by 1 to 3, and then it checks that if number is equal to 3, then we immediately break out of the loop. So it never gets to output that value of 3 because it's broke out of the loop before that. And again, I know this is something where it's really easy to make these sort of small errors, but these can be really sort of crucial errors in a sense that they might have a huge effect on what your program actually does. And that's why we are practicing this a lot. It is tricky, it was supposed to be tricky. It was intentionally tricky. I'm I'm trying to get you to answer wrong here, sort of on purpose. And the reason is that I want you all to, when you make these errors enough, then you actually learn how it's, then you learn to pay attention to the right things in this one. And it definitely is tricky at first. But don't worry, it's tricky for everyone at first, so no worries, you will get the hang of it. But yeah, so the thing about this one is also that we can use the break statement even with the while statement. And the good thing, this is actually useful in some occasions, especially, again, let's say that we're doing something really time consuming in a loop. Let's say that we're, and if we at some point realize that something went wrong, then we can break. Let's say that at some point we're talking about like how we can read stuff from the files or even over the internet. And let's say that you need to process something like 10 billion values out of the file one at a time. But then we realize that we are processing value number 500 and realize that this is wrong. There's something wrong with this. So it's a good thing that we can then break out of the loop instead of doing all those 10 billion values one at a time in a loop. So break is useful if we have sort of a longer loop, but for some reason we need to get out of that loop earlier. It's also useful for that one. It's also useful for occasions where we just create like an infinite loop with while true, and then we break out of the loop because, for example, the user enters something or something like that. We don't necessarily need to use a break. We can also have a condition for that one, but there are occasions when break is definitely makes the program more readable. Then there's another statement, continue, which is maybe a bit less useful. Again, it's something you can do without, but at least you need to know how it works. And the idea of continue is that it doesn't terminate the whole loop, but it terminates the current round of the loop. So having continue statement goes back to the beginning of the loop. So let's do something like this to demonstrate this one. Let's increase the value by 1. Start with 0 to make it reasonable. And then let's check that if number divided by 3 continue, otherwise we print out the number. What does the program between? So what happens here? Okay, let me tell you what happens here. Okay, let's try it out first. So it outputs the values 1, 2, 4, 5, 7, 8, and 10. Which numbers it doesn't output? What are the numbers it doesn't output?
9 and 3.
Yeah,
and
9,
6. And
yeah,
6.
and 6. Yeah. Okay.
Yeah. Because there is a condition saying that if the remainder when the number is divided by 3 is equal to 0, in that case continue the loop. So
yeah,
if it's 3, 6, or 9, in that case the loop is continued and the number is not printed.
Exactly. So what happens here is that we go through the numbers starting from 0. As long as the number is more than 10, we increase it by 1, and then we check that if the number is divisible by 3, we continue. And what the continue does, it immediately goes back to this line here. So continue is like saying that, okay, we're done with this loop for this round. Let's get back to checking the expression, the conditional expression. So it's like go back to this line number 3 in this case. And as I said, continue is, you can do this without doing the continue. You can do something like this to get the same effect. So if the number isn't divisible by 3, then if we execute this, we get the same exact output of. So we're missing 3, 6, and 9 in this one. And as I said, the continue isn't probably as useful as break, or at least it's not used as often. But again, it might be useful in some occasions where again you're doing like whoever is drawing something, please don't do that. Whenever you have having like a longer loop, and you're doing some heavy processing with the numbers. Let's say that you're doing a bunch of numbers and you want to know if the numbers are prime numbers, and we'll probably have an exercise about that at some point. And to finding out if a number is a prime number, the only way is to check all the possible divisors and trying to see if there are none. And if we know that we don't want to do this for some numbers, then we can use the continue to skip those numbers. The problem with continue is that you need to be careful where you use it. So what happens in this one? What is the output of this one?
Where?
What does the program output? Again, I remind you that whenever you're speaking to your microphone, it is included in the recording. So it's perfectly fine to do it, but please just remember that. So we are going to publish this as it is. I'm not going to edit out any of your questions. So, and nothing wrong with that. We've had really good questions over the microphone, but just remember that you are there in the recording speaking. So what is the output? 1, 2, yeah. Or actually not 1, 2. Yeah, 1, 2, yeah. And what happens after 2? Because that's
So
exactly right.
When 3 is the number, in that case, and the remainder is 0, it starts to continue the program again from the starting. And it never gets the chance to increase the number by 1.
Yeah.
So in that case, it again goes from 0 and then 1 and 2 and again starts the loop.
Exactly. So if you're going to execute it, what happens? It does actually output 1 and 2, but for some reason it doesn't display the 2 over there. Let's terminate the program because it creates an infinite loop. And now if we output the number before this one, it's easier to see what happens in here because it keeps on outputting 1.
Why is 2 not output?
Let's see. Because we have a wrong operator over there because we had the print statement, sorry. So now we check that the number isn't divisible by 3 and then it continues. So if we do it like this, then it outputs 1 and 2. That was really, really good. Oh, then it only outputs a 0. But let me see what happens in here. So it outputs 0. Number divided by 3 isn't true, so it increases it by 1. But why doesn't it? Shouldn't it be not equal to? Let's say I'm sort of confused here as well. Yeah, it should be 1 to 3 and then go into infinite loop or what?
Technically, I think it's because when the number is 0 and 0 is divisible by 3, in that case, it just goes.
Yeah, 0 actually is divisible, but yeah, you're absolutely right. Yeah, sorry, I'm sort of confused. We need to start by 1. 0 is divisible by any number actually, because 0, whenever you divide 0 with something, it's always 0. So now it outputs 1, 2, 3, and then an infinite number of 3s. Yeah, thank you for that. It's you can see that it's not always easy to understand, even if you're written some programs before. Very good point. Also good point that 0 is divisible by anything. But what happens here is that it actually outputs 1, 2, and 3, and then an infinite number of 3s because then it never increases the value again. It's stuck in this loop between lines 3 and 7 over and over again. It outputs 3. 3 is divided. 3 is divisible by 3, then it goes to continue, and then it does that over and over again, and stuck in an infinite loop. So when you're using continue, if you're using continue, you need to be really careful on where you update the values of your variables to make sure that you don't do an infinite loop. Yeah, continue means no. Well, there's a question. Does continue mean turn to the start of the block? Yeah, continue basically means that go to the beginning, go back to the while, go back to checking the condition. So basically, yeah, go back to the start of the block, but or go back to before the start of the block because this number 3 is not part of the block. So it goes back to this line here, checking the condition again. So difference between break and continue is that break exits the whole loop, continue exits the current round of the loop. As I said, you can do any program there is without using a break or continue. Break is quite useful in some occasions. It does make the programs more readable, what can make them more effective, can make them quicker in some point. Continue can also make the programs more readable, but I say that continue is used less than break. But regardless, it's important that you know what the continue does. How does it work? Okay, then a couple of words about nested loops. And let's do a program for that. And let's do a couple of loops. So what I'm trying to do here is to output a simple multiplication table. And we're going to see that it's not going to work as intended. But let's try it first. So what does it do? It only outputs that 1 times 1 equals 1 to 1 times 3 times 3 is equal to 3. And what I was hoping for was output all the multiplication tables between 1 and 5. And now I only get it for 1. Any ideas what goes wrong? Again, this is a tricky one. Or might be a tricky one.
So inside the loop, we also have this number 2, which says that if it is less than 3, so in that case, it just prints up to 3.
Yeah, but why doesn't it print the same multiplication for when we increase the value of number 1 to 2? Why doesn't it output 2 times 1 equals 2, 2 times 2 equals 4, and 2 times 3 equals 6?
Because there is no print command after the while number 2 is satisfied. It increases number 1, but we don't print it.
Yeah. So what happens? Yeah, you got the point. What happens here is that there are now 2 loops, and indenting these loops, and indentation is actually there was a comment for that one. It's actually okay for this one. There are 2 nested loops. The problem with this one is that when number 2 reaches value 3, this condition is then always false. So regardless, the outer loop will go on for 5 times, but because number 2 is always 3, the inner loop doesn't. So if we do it like this, then we get the output that we were probably looking for. So now we got 5 multiplication tables from 1 times 1 to 5 times 3, like this. So it's possible to nest loops. And again, you need to be really careful with the indentation. So what happens if I do it like this? Let's try it out. And now we only get like a single multiplication table from 1 times 1 to 6 times 3. So this increase belongs to this loop here, so it needs to be in this block here. And as you can probably see from this one, as you may see from this one, this can get sort of complicated quite quickly. But there are occasions where we need to use nested loops. The thing about nested, well, there are actually 2 reasons why you need to be careful with these nested loops. One is the one that even with this sort of a simple program, it's easy to miss the correct indentation or miss the initialization of variables or miss the increasing of variables or do it in the wrong step or something like that. So you need to really pay attention, or you need to be really careful on what you do and at which point. Another reason why nested loops might be sort of dangerous is that when you are nesting loops, it's really easy to come up with a program or easy to come up with loops that go on for very many times. Because even relatively small numbers, like if you nest 3 loops, which each go from 1 to 1000, which themselves is usually nothing, like doing a program that does something 1000 times, usually it's usually executed in microseconds or something. But if you have 3 nested loops and each goes on for 1000 steps, then you're doing something for 1 billion times already. And doing something 1 billion times, if it's a bit more complicated thing, may take a longer time, really long time. So nesting loops, even with relatively small numbers, can lead to a really long execution times. So this is something, if you're taking the data structures course later, which I really recommend, it's a really good course. This is something that discussed more over there, that the complexity of your program. So we're not going to talk about that much more. It's also important to realize that when we're doing these nested loops, let's see that it works in here. If I break out of a loop, it only breaks out of a current loop. So if I break out of this inner loop in here, it still executes the outer loop 5 times. So this break statement is connected to this while statement. So it breaks out of this loop from lines, lines between 6 and 9, and then it continues execution at line 11. But if I break out of the outer loop, get rid of that one, then it executes the outer loop, which also includes the inner loop. So it executes the entire program after executing the inner loop once. So when you're using break with nested statements, nested loops, you need to be really careful on where you insert the break. And there's no way to break out of the inner loop in here. There's no statement which would say that break out of this while loop starting at line 4 in this point. You can only break out of the current loop. You can't break out of anything outside of that one. Okay, nested loop. We're going to use some nested loops later, so let's continue to something else. There are still a bunch of things we need to talk about today. So let's move on to something different, and let's talk more about strings. And now we've been using strings, for example, when we've been reading something like read user's name or something like that. But now let's talk a bit more about manipulating strings, because it's really useful. Python is really great for manipulating text, and for that kind of things, we're going to need some operations for manipulating and getting information out of strings. And we're going to start today. We're going to continue this next week as well. And the first thing we talk about is the fact that each string has a bunch of characters. A string is actually something made out of, it's like a sequence made out of characters, and there are 0 or more characters in each string. There's really no upper limit in Python for the number of characters except the amount of memory you have. And when we are indexing something, we always start with 0. So the first character at each string is at index 0, and the final character is at index length -1. Meaning that if we have a string like exemplary here, which contains exactly 9 characters, then the first character is at index 0 here, and the final one is at index 8, which is the length of the string -1, so 9 - 1. And we can get a length of any string by using the len operation, or len function, sorry. So we can try it out. Something like, let's query for name. Give a name, and then we know how many name as then name characters in it. So if we try this out and we provide a name.
Name plus one.
Name plus one, sorry. Let's try this out first. So Joe, the name Joe has 3 characters. Oh, it's missing. Okay. Over there. And let's try something else. Try a name like Janet. Name Janet has 7 characters in. Now it's important to realize that Python calculates all the characters, including spaces. So if I provide something like Joe Smith, then it does have 9 characters in it. It has 8 letters, but 9 characters because space is a character as well. If I provide an empty string, then that has 0 characters in it, but it is still a string. And so we can initialize an empty string by just using two quotas like this. So this creates an empty string, which is a string, but it has no characters in it. Yeah. So we can do a bunch of things with the length of the string. Let's try something else. Let's say that we want to form a sentence 1 word at a time. So and we want the sentence to be a maximum of 30 characters, or let's say 20. Space as well, so the space between the words. And then if we try this out, something like little cow is sitting, and then, well, I'll put the sentence at the end to make it show something of the outcome. This, let's do it again. Little cow is sitting, and then the sentence is little cow is sitting. So this while loop goes on as long as the length of the sentence is less than 20. And then we just keep concatenating the words at the end of the sentence. And then whenever we concatenate a word, we also add a space. This means that there's also a space at the end of the string, although it's not visible, but that affects the length of the string, for example. Okay, so now we know that the character has indexes between 0 and the length -1 of the string. So what we can do with that information is we can extract characters from a string by using these brackets. And the idea is that we provide a variable or string constant, and then these brackets after that one, and then inside the brackets, we provide the index of the character we want to pick. So if we again query for a name, then we can display that the first character is at index 0, and the second character of that name is at index 1. And this is something that might be confusing at first. Because we start indexing at 0, it means that the character at index 1 is the second character, not the first one. Something you just need to remember.
Can we also put like inside the brackets, like the last character is name bracket length of string -1?
Yeah, definitely. Let's do that. Let's do that after we try this one. So let's have a name here like Anne, and now we see the first character is A, the second character is lowercase n. Something else like Timothy, and the first character is T, and the second uppercase T, and the second character is I. So we can pick individual characters, and that was a good point. We can also get the final character. And we can use the length for that one. So let's pick a character which is at the length of the name -1. So let's try this out. Let's have the and again. So now it displays that the final character is this lowercase c, which is the final one. And this works for any name where there is a final character. Okay, what happens if I provide a name with just one character? Let's say that my name is X. What do you think will happen?
In that case, error will appear.
Yeah, there will be an error, and the error, it displays the first character, which is X, but it can't display the second character because there is no second character. And the error is actually error message is quite informative, stating that string index is out of range. So we're trying to use an index that's not present in the string. It doesn't occur in the string. There's no index 1 in the string because there's only one character. We can output the final character, of course. So if we comment this one out and we execute the program again, we again give a name with just a single character like X, then it outputs the first and the final character of both X's, and that's true in this case because there's only one character. It's question why to -1? -1 because the final character of the string is at length -1. And if you take a look at this example here, there are 9 characters in the string. If we try to get the character at the index, which is the length of the string, that's also an error. There is no index 9 in the string, although there are 9 characters. And the reason for that is that we start the indexing at 0. So the first one at 0, the final at length -1. In Python, actually, we can also refer to final item by using a negative index. So we can say state -1. And now this isn't an error, but instead it refers to the final character of the string. So if I provide a name, something like, and again, it states that the final character is lowercase c. And this means that any character in a string has actually 2 indices. It has the positive index starting from 0, which is the first character, and it has a negative index starting from -1, which is the final character. And this is useful if we need to work backwards from the end of the string. You need something like the final or second to final character or something like that. Then we can use negative indices instead of using the length -1. The length -1 also works, but it's easier to just type -1 instead. This is really something Python specific. This isn't usually in a lot of other programming languages. You can't use this -1 because, well, it's not implemented. Okay, we can also, let's use the character thing in a loop. Let's create an index that starts from 0, and let's say that while the index is smaller than the length of the name, then let's print out a character at index, and then we remember to increase the index by 1 so we don't create an infinite loop. What does the program do? What do you think the program does? Yeah, it prints the name letter by letter 1 at a time, starting from the first one. Yeah. So if we have a name like Timothy, then it outputs the characters 1 at a time, and regardless of what the name is, how long it is, or anything like that, it still displays the characters 1 at a time, starting from the first one. This is useful because, again, in a lot of occasions, we may want to go through the characters in a name, and let's say that we want to do something like, let's pick the character first, and we can check that if character is space, then let's increase the spaces by 1. We need a variable for that one, of course. There are other ways to do this, but we'll talk about those later. And then remember to what is this? Is wrong? Oh yeah. Okay. Like this. Sorry. Yeah. Okay. What does the program do? after all that hassle with the indentations. What is the outcome of the program? We could say it doesn't really do anything because it doesn't display anything at the end, but what does it do?
It increases the space.
Yeah, it increases it, but what does it? What is like the practical result? What value does the spaces variable hold after executing this program? Yeah, it counts spaces in a string exactly. And what can we do with that information? Why? I mean, at least in some implications. Some occasions. Why is
Can I answer?
Yeah, please.
Because spaces plus 1 gives us the number of words.
Yeah, exactly. So the number of spaces actually provides us the information about. We can actually query for something other than name. Let's change it to something like sentence instead. And then we can state that there are spaces plus 1 words in that sentence. And why plus 1? Because space is the space between the words. So if there are 2 words, there's the 1 space in between. And then we can see if it actually works. Let's try it out. Little red cat ran over the road, and it now tells us that there are 7 words in that sentence, which might be useful. There are other ways to do that, but still. The idea that we can go through a sequence of characters, to go through a string 1 character at a time, is useful in a lot of occasions. We can do a lot with that operation. We can calculate different characters in a string, for example, try to locate different characters in strings or things like that. We can do this with while loop, or we can do it with other tools, which we're going to talk about later, but as an example. In addition to getting individual characters from strings, we can also get substrings or slices out of a string. And the difference is that substring may contain 0 or more characters. So for example, if we have, again, this example word exemplary, we can take a substring, for example, between indices 2 and 6. So we get a 4-character substring which contains characters E, M, P, and L. And substring is a new string always. So it gets the part of the original string. The original string doesn't change. Strings in Python are immutable. We can't change a string in Python, but we can create new strings based on the original string. So in this case, and what you need to remember when you're using the substring operation, now there's a tip, it's a wrong character over there, it seems. But when you're using the substring operation where you provide the beginning and end, then the begin index is inclusive, but the end index is exclusive, meaning that substring between 2 and 6 get characters from 2 until 6. So it gets characters at positions 2, 3, 4, and 5. So let's again query for a name and then output a substring between 1 and 3, for example. Oh, it wasn't a name, it was a... I forgot that I changed the name of the variable. Do it like that. And now, if we have a name like Timothy, then the substring contains from 1 to 3 contains characters 1 and at positions 1 and 2, which in this case are lowercase I and M. Or if we take a substring from 2 to 5, for example, and then let's give a name B, C, D, E, F, G, and so then the characters are C, D, and E. So we start from index 2, which is a 3rd character in the string, so the C, and we go until index 5, so we get characters from indices 2, 3, and 4. Substrings are also quite useful, especially when we're using them with other operations, so we can, for example, extract words out of a string or something like that. We're going to talk more about these later as well, but we're going to start practicing them this week. There are, but as I said, one thing you need to remember is that the begin index is inclusive and end index is exclusive. We can also omit begin or end index, meaning that if we only provide a start index, then Python takes a substring starting from that index until end of the string. So if we have, again, a name like James, then starting from index 1 until the end of string, picks all the characters except the first one. This is also great if we can also omit the index at the beginning, so then it starts at the beginning and goes until the end. And this is, what does this do? What does this do is what I'm trying to ask here. What is the meaning of this one? So take a substring until -1. What is the effect? What is the result?
So it starts from 0 and it goes all up to the end character, so gives you the word.
Yeah, but that's exactly true. But what effectively happens here? Let's say that I provide a name like James for this one. What is the outcome? What does this output?
James itself?
Sorry, what was the?
James itself?
No, not exactly. It doesn't output James. What does it output? Remember how the substring operation works. It includes the character at the beginning, but it excludes the character at the end. Yeah, it outputs James. So it leaves out the final character. Why is this useful? Again, it's useful because if we, instead of name, we are querying for a sentence, for example, and then let's do this. And little red dog run over the street. And then what it does, it gets rid of the final character of a sentence, which usually is it's like a dot or exclamation mark or something like that. So if you want to get rid of that one, we can just take a substring until the final character. And because the final character is not included in the substring, it gets rid of the final character of the string, which is, again, surprisingly useful in a lot of occasions. Okay, we're sort of running out of time here, so let's move forward. The in operator returns true if substring can be found in a string, and it returns false otherwise. So it's useful. Let's check that if dog in sentence, then print you're probably talking about dogs, and if not, talking about something else. So if we try this one out now, if we provide a sentence where there is a dog is over there, and then the in operator returns true because this substring dog can be found in a sentence. But if we provide a string that doesn't contain the substring dog, then it's the in operator returns false. Now it's important to realize that whenever we're manipulating strings and dealing with strings, the character, the uppercase characters are different to lowercase characters, meaning that now since we are looking for dog written exactly like this, if I do something like dog is here, then it says that you're talking about something else. So it can't find the substring dog in the string dog is here because it's not written in all lowercase characters like it should be. In addition to in operator, we can also try to find the or can find the index of a substring in a string. So let's say that the index equals sentence, and then we try to find doc in there. For some reason we're dealing with docs today, and it's just output index. So if there is this substring doc in the sentence, like doc is here, then it outputs 2, because 2 is the index where the substring starts in here. It starts in 0, 1, and 2. So this is the substring found. If the substring cannot be found in a string, then it's just the find method returns -1. So it's not an error, but returns -1, indicating that you can't find. If there are more than one of that substrings, then it returns the starting index of the first one. So meaning that for this string, it returns 0 because that's the starting index of the first substring doc inside this whole string. Okay, I'm going to, regardless that we are sort of running out of time, if you need to leave, then you need to leave. No worries. Let's, yeah, I'm introducing a find method in this one. Yeah. Okay, so let's combine this a little bit. So let's say that let's find the index of the first space in a string. You can do it like this, and then let's find the second word based on that. No, let's find the first word. Second one is a bit more complicated. First word is in, and then in sentence we can take a substring until the space, and then we can output that the first word is, and then it's going to be in variable first. And let's see if this works. First word, like that. So let's try something like elephant is sitting in the yard, and the first word is elephant. And now yeah, I'm actually, the dot is actually not combining functions in this case, but what we're doing is we're using something called a method, which is also a function, but the function that's directed towards this variable or this string in this case. So the way to use the index function is it was the find. Actually, the index actually does pretty much the same thing than the index in a lot of occasions. So, but the idea is that the find is now directed to this string in here. If there is no space in a string, yeah, that's a good question. What will happen? Let's provide a string with no. And now it says that the first word is hell, which is actually not true. Why does it work like this? Well, the find returns -1, and then we take a substring until -1, which in practice takes a substring excluding the final character. So what we can do in this one is check that if there is a space in sentence, and do it like this. And then if there isn't, we can say that the first word is the entire sentence in that case. So now it should work. Not provide any profanity. So hello, the first word is hello. So now it works. And that's a good question, because whenever you're writing and testing your programs, it's important that you think about the special cases, like what will happen if there's no space in string. That's a really good question. And that's something, that's like a mindset I hope you will sort of develop at some point, that when you're testing your programs, you think about all those And that can be really difficult at first. But you think about those special test cases, like okay, I'm trying to find the first word of sentence, but what if there are no, what if there's only single word in a sentence? What if there are no characters in a sentence at all? And things like that. Because when we are reading data from the user, it's perfectly possible that there is something wrong with the data, in a sense that there might only be a one word in a sentence. And it's possible to have a sentence with just a single word. So that's really good. That's something you should try to think whenever you're testing your programs and writing them. The final thing for today, which I'm going to introduce quite quickly because it's our main topic next week, are our own functions. And the idea of a function is that we can include some code inside a function, and it's only executed when we call that function. And I'm going to show you a practical example. Let's do this. Sort of a dummy function which just displays a message. And now if we execute this program, it seems like nothing happens. And the reason is that the code inside a function is only executed when I call the function. And I can call the function by just typing the name of the function. Name of the function acts as a sentence, as a statement. And now when I call the function, now it executes the code inside the function, so it outputs the greeting. If I call the function several times, it then executes the same function 3 times, so it displays the same message 3 times. And this is already an indication why the functions are useful. Whenever we have code, we need to execute at different states of the program. We can write that inside a function, and then whenever we want to execute that code, we can call that function. The functions are also great because that means that when we are writing a longer program, we can divide it into individual functions. So we don't need to have one single long program. Instead, we have these smaller functions. We also call them sub-programs. Smaller functions, and then it's easier to write the code one function at a time. It's easier to test the code one function at a time and so on. But we will talk about this later. The function is defined with the keyword def, which is shortened for define. So we define a function. We provide a name for a function, which can be anything, but again, we want to use a name that's somewhat meaningful. And then we have a parenthesis after that one. And inside this parenthesis, we can have something called parameters. I will introduce them shortly in a minute. And then we have a colon, and then we have the body of a function. And then all this code inside the body of the function is executed when we call the function. We can have any code here. Let's do something like index equals 0, and while index is smaller than 5, let's output the word hello. So now when we call the function, and then let's remember to increase the value of index by 1. So now when we call the function, it now executes this block, and it displays the word hello 5 times, like this. But functions exactly like this are, well, they can be somewhat useful, but the fact that the function does the same exact thing each time makes them less useful. And that's why we can have something called parameters. And now this is something we're going to talk a lot at next time, but something I also want to introduce at this week already briefly. And the idea is that we can provide variable values for this function. So let's have a parameter called message here. And so we have a variable in here, but the variable doesn't have an initial value. And now instead of printing hello, we can print the variable message. And now you see that when we are writing a function, we don't know the value of this parameter. And as Python states here, or the editor states here, that message is any, so it can be any type and contain any value. But what we do is we output the value of this variable message 5 times. And now when we call the function, Let's call it and then provide a value. Now we provide a value for that variable. So what happens when I execute this program? Any ideas?
So it prints the whole message.
Yeah. And what is the message?
Hi there. Hi there. I think.
Yeah, exactly. So hi there is a message, and now it displays the message hi there 5 times. If I change the message, if I call it with another string, for example, hello, then it displays that message hi 5 times. And again, I can call the same function several times, and I can provide a different message when I'm calling it each time. And now it displays a total of 15 lines of messages. So 5 hellos, 5 hi there's, and 5 howdies at the end. So meaning that when we are calling the function, we provide a value for this message variable. It's called a parameter. And it's something, as I mentioned, we're going to talk a lot more next time about the actual mechanics in here. But in this week, let's try with this simple idea that we can provide different values when we call this function several times. And this is really useful. The same loop in here displays the message 5 times, but we can change the message when we call the function. It doesn't need to be a string. It can also be a number like this. Then it just outputs number 155 times. But we provide a value for this variable when we call this function. The variable, why is the output hello, 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 and not hello, howdy, hi? Because when we call this function with this message, then the function is executed at the end, and then it gets back to wherever we called it. And so when I call it with hello, it outputs the hello 5 times, and then it exits. And then the program can do something entirely different. And then we can call it again, but we can provide a different value if we want to. So now it outputs hello 5 times, then it displays the message hello for that, thanks for that, and then it calls the function again. So the function calls are independent. Whenever we call the function, the whole function is executed, and then when the execution is done, then it returns back to the main program here. And I think this is pretty much what we have time for today. There are some additional things in the material. Please scroll through that. There are especially something about testing your code, and the idea that when you're testing your functions yourself, you need to include your main program inside this block. I'm going to tell you later what it means. That's not really important today. Just follow the examples and instructions in there. And then next week, we're going to dig deeper to those functions. We're going to really try to understand what is the idea of functions, what happens when we provide parameters, what are the things like arguments and parameters and so on. And then next week we also start talking about data structures, which start with lists. We see how we can store a lot of data into a single variable, like different values into a single variable, which is also quite useful. But that's next week. This week it was about loops, about repetition, about basic string operations, and a little bit about functions. And that's what you need to learn to do this week. Remember to ask for help if you have any problems. Remember the Discord. Remember the live workshops in Kumpula Campus. If you can attend those, please do. And remember that you can also send me messages if you have problems. So thank you for this.